Okay, so we've been talking about factoring. The reason why we kind of talk about it is so that we can use it to solve an equation. Um, so you can use factoring to solve certain types of quadratic equations. Quadratic equation, one variable can be written in the form of ax squared plus bx plus c equals 0, where a cannot equal 0. This is called standard form, which we talked about when we dealt with graphing parabolas. Um, the only way this works is if I can have everything on one side and 0 by itself, but it can be factored that an equation can be solved using the zero product property. If you guys remember, I'm saying that a times b equals 0, either a equals 0 or b equals 0. Okay, so I can do 0 times b, that's going to equal 0, or a times 0 is going to equal 0 as well. So what I'm trying to do is try to use factoring to solve this equation. First thing is make one side equal to 0. That's the first thing we do. Okay, the second step that we're going to do is to factor. Okay, so I'm taking x squared minus 18, and what gets me x squared is going to be x and x, and what gets me negative 18. Negative 6 and 3, negative 3 and 6, negative 2 and 9, negative 9 and 2. And I'm going to choose negative 3 and 6 because if I add those two, I get 3x, which I'm looking for. So I have 6x, or 6 and negative 3. So I have 6x minus 3x. That gives me 3x that I'm looking for. So my factored form is x plus 6, x minus 3 equals 0. So to solve this, I'm going to set each of these quantities equal to 0. I'm going to say x plus 6 equals 0, x minus 3 equal to 0. The reason why I'm doing that is I'm trying to figure out what can I put in place of x that makes this quantity 0. So if I subtract 6, I get x to be negative 6. What can I put in place of x that makes this 0? So if I add 3 and add 3, I would get x to be 3. So if I were to plug negative 6 in, negative 6 plus 6, negative 6 minus 3, does that get me 0? I got 0 times negative 9, which is 0, so that checks out. If I plug net 3 in, 3 plus 6, and then 3 minus 3, does that equal 0? 9 times 0 equals 0, so that checks out. Okay? If I were to plug this into the original equation, just choose one of them. I'll choose the 3. If I do 3 squared plus 3 times 3 minus 18, does that equal 0? 9 plus 9 minus 18 does equal 0, so that's factorable. Okay, so let's do one more. Looking at this one, remember the first thing I want to do is set one side equal to 0. So I'm going to subtract 3x and add 5. So right now I got 2x squared minus 20x plus 45 plus 50 equals 0. When I look at this, I can see that 2 goes into all of this. I'm going to divide everything by 2. So I have 2x squared minus 10x plus 25 equals 0. So factor this out. I have x squared plus 25. So I have 1x and 1x. And then what gets me 25? 5 and 5, right? But I'm going to make it negative 5 and negative 5. So if I add negative 5x and negative 5x, I get the 25 I'm looking for. So my factored out form is 2 times x minus 5, x minus 5 equals 0. If I set x minus 5 equals 0, you get x to be positive 5. And I would get that twice. So let's just say we have one more example. And we're looking at 9x squared minus 12x plus 4. So one side is equal to 0, so we're set with that. So we're going to factor this out. I have 9x squared plus 4. And if I try 3x and 3x plus, well, 2 and 2, I know that gets me. So I'm going to make it minus 2 minus 2. So you get minus 6x minus 6x. So you have 3x minus 2. 3x minus 2 to be the factored out form equal to 0. So I'm going to set both of these equal to 0. I'm going to add 2. So I got 3x equals 2. X turns out to be 2/3. Okay? That's how we solve an equation. I'm going to ask you guys to try the next few. We'll talk about the rest later.